Hello everyone, this is Deep. Welcome to ChemE-Shiksha. This is the second video of this channel and the second video of the pump lecture series. So today we'll talk about the basics and the working principle of centrifugal pump and reciprocating pump. So as we have talked in the previous video about pump, so pump is a hydraulic machine which actually converts the mechanical energy into hydraulic energy or the pressure energy, and the centrifugal pump, it actually converts the mechanical energy into pressure energy by means of the centrifugal force by means of the centrifugal force. So as the name suggests, this pump employs the centrifugal force to lift liquids from a lower level to a higher level. So there are three components of centrifugal pump. The rotating component, that is the impeller, also called the rotor. We have the volute casing, and there is another thing that is the optional part. It is the guide vane ring or the diffuser ring. So this is a diagram of centrifugal pump. This is with without diffuser ring and this is with diffuser ring. So you can see this is the impeller part. Okay, this is the eye of the impeller. This part is the volute casing and this is the diffuser ring. This part is the diffuser ring. So how this centrifugal pump actually works? So when this impeller, when the impeller will rotate, the fluid will be sucked in this eye of the impeller. This is the eye of the impeller part. So when this impeller will rotate, the fluid will be sucked in this eye of the impeller and the fluid will be sucked in the perpendicular direction. Then this fluid will flow in the radial direction. That's why the centrifugal pump is also called the radial pump. So after the suction of the fluid from the sump, the fluid will flow in the radial direction through the impeller eye. So when the fluid enter in this eye of the impeller, it has both the radial velocity as well as the tangential velocity, which is imparted by the rotating motion of the impeller blade. Now when this fluid will comes out of this impeller blade, this is the impeller blade. So when this fluid will come out from this impeller blade, it has some kinetic energy because the impeller blade, it will impart some amount of kinetic energy on the fluid. So the kinetic energy of the fluid will increase. Also at the same time there is a change in the static pressure while it flows through the impeller blade, because the impeller blade is diverging in nature. In the direction of flow, its area is increasing. So that's why, as we know from the continuity equation, that is A into V is equals to constant. So AV is equals to constant. A is the area of the flow area, and V is the flow velocity. So as this, in this direction of flow, the area is increasing, so velocity will decrease. As the velocity will decrease, the kinetic energy will decrease, and we know that as from the Bernoulli's principle, as this kinetic energy will decrease, pressure energy will increase. So that's why I told you that the static pressure will be also changed, static pressure will also increase. So therefore in the centrifugal pump, the pressure head is actually increasing from this inner part of the blade to this outer part of the blade. Also in this volute casing, this is the direction of the flow. So in this flow direction, you can see in the volute casing also the area is increasing. So again, from this continuity equation you can say, as the area is increasing in the direction of flow, the velocity must decrease, and as the velocity is decreasing means the kinetic energy also decreasing, means the pressure head is increasing. So in this way the centrifugal pump, via its centrifugal force, it will increase the pressure head of the fluid. Again, if we need much more amount of heat, then there is the diffusing or the guide fairing. So this diffusing is also diverging in nature. So now in the flow direction, its area is also increasing. So it will also help to increase the pressure head. So whatever I told you, this is written in this PPT. Now the reciprocating pump. So we told you that there are two types of positive displacement pump. One is the reciprocating pump, another one is the rotating. One is the reciprocating pump, another one is the rotary pump. So in case of reciprocating pump, the we can see that there this is the chamber of the pump and this is the piston. So it can be piston or plunger or might be diaphragm. So the energy transfer takes place by changing volume of the fluid by physical displacement. So when this piston will move in this direction, in the inward direction, so it will compress the liquid, and when it will move in this outer direction, it will actually create some vacuum inside it. So it uses a piston or plunger to move the liquid back and forth in a cylinder executing a reciprocating motion. So that's why it is called the reciprocating pump. So when the piston will move in this outer direction, this is the outer direction, when this piston will move in this outer direction, then the pressure inside this cylinder will decrease. So as the pressure will decrease, due to this the liquid will transferred from this sump. This is the sump. So from this sump the liquid will transfer to this cylinder, because as the pressure is decreased in this part, so we know from the higher pressure to this lower pressure region the liquid will flow by this inlet valve. At the end of this suction stroke, so this is the suction stroke when the piston will move outward direction, and at the end of this when the cylinder will filled with the fluid, then the piston will move in this inward direction and the pressure inside this cylinder will increase as this piston will compress the fluid. So at that time the inlet valve will close and the outlet valve, there is this outlet valve, it will open and the fluid will discharge at a higher pressure through this delivery pipe. Now, a reciprocating pump is typically employed in situations where accurate fluid delivery is essential and high discharge pressure is needed. So, the reciprocating pump is actually used when we need a higher head. So, in different industries like chemical and hydrocarbon processing industry, like oil and gas extraction and transportation system, municipal water supply and wastewater management, and industrial facilities involved in water treatment processes, we use this reciprocating pump. Now the flow through this type of pump is constant if the stroke length and stroke volume remains constant. So that's why it is called the constant flow pump. So even if we change the suction or the discharge pressure, then also if my stroke volume and stroke rate or the stroke length is same, then there will not be any change in the flow. So that's why it is called the constant flow pump or the metering pump. So the flow of the reciprocating pump is actually equals to the stroke volume into number of strokes. Now this stroke volume can be written as the stroke length into area, now into this number of strokes. So for single acting reciprocating pump, Qt is equals to A into L into N by 60. A is the area of the flow of the cylinder, L is the stroke length, and N is the speed. And for double acting reciprocating pump, Qt equals to 2 into A into L into N by 60. So this picture we can see over here, it is a single acting reciprocating pump. In case of double acting reciprocating pump, what will happen? Now let's say this is the cylinder and we have the piston over here. So when this piston will move in this direction, at that time in this part there will be suction stroke and in this part there will be discharge stroke. And in the opposite case, when the piston will move in this direction, it will compress this part of liquid. So in this part there will be discharge stroke and in this part there will be suction stroke. So this is the double acting reciprocating pump. So in that case we have the Qt is equals to 2 times ALN by 60. Now there is a problem in reciprocating pump, that is the pulsation problem. So problem of pulsation in reciprocating pump, as at a single time it can only operate suction or discharge of fluid. So the problem of pulsation or vibration, it is for single or reciprocating pump. If we have the duplex or double acting reciprocating pump, then this kind of problem is not there. Now so that's why it is written that to reduce the pulsation problem, we can use the double acting pump or the duplex reciprocating pump. But what is this pulsation problem? Now this pulsation problem is actually because of the intermittent back and forth motion of the piston. So as in case of single acting reciprocating pump, there is at a time there will be in either suction or discharge. So that's why this problem is occurring in case of single acting reciprocating pump. But in case of double acting reciprocating pump, at a single time there will be, at one part there will be suction stroke, another part there will be discharge stroke, and at the next time the opposite thing will occur. So that's why this back and forth motion of the piston or the plunger, it will not cause any pressure fluctuation inside the fluid. So that's why in case of double acting or duplex reciprocating pump, this pulsation problem is not there. But in case of single acting reciprocating pump, there is a problem of pulsation. Now this is the difference of centrifugal pump and reciprocating pump. So the centrifugal pump, the principle of centrifugal pump is centrifugal force. Because of this centrifugal force, the mechanical energy is converted into the hydraulic energy or the pressure energy. And in case of reciprocating pump, it is the reciprocating motion or the positive displacement of this piston or the plunger inside the cylinder, which is actually the main driving force or the principle of this kind of pump. Now in centrifugal pump the flow is continuous, but in case of reciprocating pump it is pulsating. So if it is single acting reciprocating pump, then it will be pulsating, otherwise there will not be this problem. Now priming, what is priming? I will tell it in the later video what is priming. But in case of centrifugal pump, this priming problem is there. There is a problem, so that's why we need to do this priming. Priming is required in case of centrifugal pump, but in case of reciprocating pump this is not required. Now the speed, reciprocating pump has a high speed than the centrifugal pump has the higher speed than the reciprocating pump. The discharge as I told you that it varies with the speed for centrifugal pump, but for reciprocating pump it is constant. So that's why reciprocating pump is called the constant flow pump or the metering pump. Now the maintenance for centrifugal pump is lower than the reciprocating pump. The head, as I told you, that reciprocating pump is used for a higher head, so the head developed by this reciprocating pump is much higher than centrifugal pump. Now the problem of pulsation, noise, vibration, this is present in case of reciprocating pump, not in case of centrifugal pump. Efficiency is medium in case of centrifugal pump, and for reciprocating pump it is high at low flow. The application for domestic, industrial and irrigation cases we use centrifugal pump, whereas when we need higher pressure or higher head, in that case we use the reciprocating pump. So that's the end of this video. Please subscribe my channel. If you like this video, please hit the like button, share with your friend, and be a part of a growing network of future ready chemical engineers. Thank you for watching this video.